Okay, so little different. Well, not much. So let's get the region bounded by what? Did it again. X equals square root of y. X equals 0. And y equals 3. So what does that region look like? Well, we could do a couple different things. One, we just need a quick sketch. So if I sketch this one, the square root, let me put a few values in. 1, 2, 3. 1, 2, 3, 4. So for that one there, we know 0, 0. 1, when y is 1, x is 1. When y is 4, x is 2. Just plugging in here. Since x is in terms of y, so let's see here. X equals 0 is the y-axis, and y equals 3 is the horizontal line. So there's the region. Now I got a couple different avenues, but let's go ahead. I'm going to put this in here for that parabola looking thing. Actually it is. Let's use this rectangle this way. So this horizontal rectangle, in fact all of those horizontal rectangles, so going from that x to that x. So our quote height is delta x. Well, this is x comma y, of course, as an ordered pair, but we need this in terms of y because we're adding these rectangles in the y direction. So how can we transform that? Well, think about what we did. We plugged in y values, which we knew, and then what do we get for x? What do we find for x? Well, we took the square root of y. So that's a different way we're going to be using more and more, changing these ordered pairs this way. And of course the axis is 0. So big minus small. This time it's right minus left. So square root of y minus 0 is boring. That's the height times your base. And we're going to add them up from 0 to 3. And now we integrate. Now we can forget about what we're doing here and just integrate normally. So that's y to the 3 halves. Divide by 3 halves from 0 to 3. 2/3. Not y. Gotta plug in 3. Minus 0 to the 3 halves. It's 2/3. 3 to the 3 halves. Well, 3 to the 3 halves, if we try simplifying, which we may have to do the match up, for response I would be okay with this, but if we're matching multiple choice, 3 halves is, or 3 to the 3 halves is really 3 times 3 to the 1/2 power, or 3 to the first times 3 to the 1/2 power. 1 and 1/2. That's, this time mixed numbers actually help. So this could be 2 square roots of 3. Because that's what that is. Times the 2/3. Okay. So if the region, we could do it either way. If we solve for y instead and did our normal way, we'd get the same thing. It might be just as easy or quick, whatever, for that one. Let's look at the one we saw in the other practice with the split regions. So that was bounded by y squared equals x plus 4 and y equals 2 minus x. That's a nice good straight line. Let's try it again. Ooh, that's better. Again, when x was negative 4, if I'm graphing that parabola. We do need some markings down. So graphing the parabola, when x is -4, the y-intercepts are plus or minus 2. Again, that's when x is equal to 0. We had that curve. Graphing the line, y-intercepts 2, slopes -1. Okay, so what we looked at the other day, or in the other one, is we had to split it up into two because those boundaries for this one was upper parabola, positive case of the square root, negative case of the square root, and then over here we had to do the line minus the lower case. Well, that means we had to split it up into two. Let's not do that. What are we going to do instead? Well, notice if we draw a horizontal rectangle, say, okay, what about, let's look at it in terms of y, this way. All the boundaries, all of those rectangles go from the line on the right to the parabola on the left. The line on the right, parabola on the left, and so on, and so on. And then all we'll have to do is add up all those going that way. Okay, so again, xy, remember this, look at it, this is a delta x. Our heights are changes in x's, so we need to get both of these solved for what x is, because of, again, plugging in x values, the parabola turned out to be y squared minus 4 is x. The line, let's see, add x, subtract 2, subtract y. So for the line here, if we know what y is, x is 2 minus y. The parabola would be y squared minus 4 comma y, because again, we'd probably plug in the y, find x. So right minus left, large minus small gives us a height, so the line minus the parabola. So there's the height of each of those horizontal rectangles times your base. From where to where? Well, that means we get it. Okay, so let's go back from what y value? What y value is this down here? I'm not going to guess because you know that's not accurate. So we would just go y squared minus 4 equals 2 minus y. Typical thing, because again, quadratic, so -3 to 2. And now we integrate just as we normally always do without worrying about any of the other stuff. First we'll simplify. So 2 minus a -4 minus y squared dy. So we're integrating, we're adding all those horizontal rectangles, we're stacking all those little areas up to add them up, or those little itty bitty rectangles. So 6y minus 1/2 y squared minus 1/3 y cubed from -3 to 2. Plugging in 2, plug in -3, which is nice because I'm seeing minus a negative here, which is going to give me a positive. And let's see here, get all that up together. Let's see, this is going to be 12 minus 2 minus 8/3 minus a negative 18 minus, that's 9/2, negative 27, negative 9, so that's minus a negative 9. So 10 minus 8/3. See, negative 9, so that's really plus 9, plus 9/2. Oops. That's just 19. Minus, here's your 19. Minus 8/3 plus 9/2. So something over 6. So so that's like what? 121 14 minus times 2 times 3 so 114 plus 27 minus 16 gets us 125 over 6. And done. That's it. So sometimes horizontally, or changing your viewpoint in terms of your integral, would be better in terms of the region as opposed to always doing dx. With practice, you'll see it better.